Hello everyone. Today we're going to continue our look at the sine law, starting with the assignment from last class. Question number 3a, we need to find side length z. We know 2 out of 2 in this side angle pair. We know 1 out of 2 in this side angle pair. So it's a straightforward application of the sine law, and we get side length z is 876.4 meters. For 3c, we need to figure out what side length p is. We know 2 out of 2 in this side angle pair, but we know 0 out of 2 in this side angle pair. However, we can find this angle because we know 2 out of 3 angles in this triangle, and this turns out to be 106 degrees. So now that we know 1 out of 2 in this side angle pair, we can apply sine law straightforward, and we get p is 54.3 centimeters. On to 4a, we need to know angle A. We know 2 out of 2 in this side angle pair. We know 1 out of 2 in this side angle pair. So it's a straightforward application of sine law to get angle A. Make sure we take the sine inverse of the number at the end, 29.9 degrees. For 4c, we need to figure out what side M is and what angle N is. We can start by figuring out what angle N is because we know 2 out of 2 in this side angle pair and 1 out of 2 in this side angle pair. So we eventually get N is 24.8 degrees. And then now that we know 2 out of 3 angles in the triangle, we can subtract them from 180, and the rest will be angle M, which is 74.19. And then once we know that that's 74.19 degrees, we know 1 out of 2 in this side angle pair, and we can use L over L and get M is 14.9 centimeters. Now let's have a look at example number 4. Miguel needs to calculate the height of a tree that he will be removing. The tree is leaning at an angle of 85 degrees with the ground. He is 30 meters from the base of the tree and calculates the angle of elevation to the top of the tree to be 32 degrees. What is the height of the tree? So we need to figure out what this side is. At the moment, we cannot apply sine law directly because we would need to know at least 2 out of 2 in either this side angle pair or this side angle pair. Because we know 1 out of 2 in this side angle pair, we can apply M over sine M, hopefully, with some other side angle pair. So it looks like maybe, because we know 2 out of 3 angles in this triangle, we can figure out what angle T is by going 180 minus 32 minus 85. So 180 minus 32 minus 85 will give us an angle of 63 degrees. So now that we know that this angle is 63 degrees, we know 2 out of 2 in this side angle pair, we know 1 out of 2 in this side angle pair, so now we can apply sine law. So T over sine T, and plug in what we know. So we don't know M yet. We know angle M is 32. We know side length T is 30. And we know angle T is 63. So now we can multiply both sides by sine of 32. So we would have 30 sine of 32 divided by sine of 63. So do this multiplication on the top, 30 times sine 32, then divide by sine of 63, and we get M is 17.8. So now I'll have a look at number 5 on the next page. A communications tower is stabilized with guy wires. One wire is 3.7 meters long. A second is attached to the pole 1.25 meters higher than the first. From the same anchor point, the angle made between the two wires is 10 degrees. What is the length of the second wire? So we can start by labeling a few angles and sides. We can call this angle A, that's side length A. This angle B, that's side B. And angle C in there, and side C is what we need to figure out. So at first we can't really apply sine law directly to figure out what side length C is, because we know 0 out of 2 in that side angle pair. We know 2 out of 2 in the side angle pair of B and B, and we know 1 out of 2 in the side angle pair A and A. So to start, we can figure out what angle A is using sine law. So we can go sine of A divided by length A, which is 3.7, equals sine of B, B is 10, divided by length B, which is 1.25. And now we isolate for sine A, so sine A then is 3.7 times sine of 10 divided by 1.25. We figure out what this number is. We need to take the sine inverse of it. So sine inverse of 0.5139 and so on. That gives us angle A is 30.9 degrees. And now that we know angle A, we can figure out what angle C is. Because we know 2 out of 3 angles in this triangle, angle C is then 180 minus 30.9 minus 10. So that'll give us 139.1 degrees. And now we know 1 out of 2 here. We can reuse B and B and reapply sine law. We can do sine C over length C equals sine B over length B. Sine C, 139.1 divided by length C equals sine of 10 divided by 1.25. And now we need to isolate for side length C, so we can multiply both sides by C, multiply both sides by 1.25. So we would eventually get 1.25 sine of 139.1 equals C times sine of 10. Divide both sides of this equation by sine of 10, and we'll eventually get C is equal to 4.7 meters. So your assignment for the day is page 267, number 6 to 8, and I'll see you next time.